Hey, welcome to Ones and Zeros. My name's Ben, and today we're going to be looking at episode number 9 of our Discovering STM32 series, which will be part 4 of our work on the LCD display. So, as mentioned during the last episode, this time we're going to be focusing on looking at fonts and getting text rendering and things like that happening. So, that's kind of the plan of attack for today. I'm gonna have a look at sort of the tools that I use in order to be able to take typical TrueType fonts in Windows and convert them over to a particular format that works quite well for using with the STM32 microcontrollers. Gives us fonts that take up a fairly small amount of space, so we can actually manage to store them in the flash memory and then look at developing the particular classes and bits and pieces that we need to be able to get that all integrated into the rendering code that we worked on last time. So for those of you that checked out the last episode, you'll recognize what we're seeing on the screen here, where we managed to get some of the rendering code started. So being able to draw things like lines and rectangles and filled rectangles, things like that. You might also notice that the camera quality is quite a bit better this time around. So a big shout out and thank you to my good friend Erin for helping out with that one and providing what is an absolutely amazing camera that we can use to be able to keep an eye on the devices that we're playing with, which has also allowed me to do a bit of an upgrade on the webcam as well. So rather than having to use the built-in webcam from the laptop, I've now got a much better setup. So all around happy that things are looking a little bit better, and also a big shout out to the few more subscribers that I've got on YouTube now as well, and the new follower on Twitch. So again, super happy that people are actually finding the stuff I'm doing interesting. And yeah, if you like what you see, definitely love it if you follow on Twitch or like and subscribe on YouTube. And as I've said a bunch of times, feel free to provide any feedback that you want. If there's any sort of things that you want to request, definitely feel free to either leave a comment or jump onto our subreddit r/ones and zeros, leave a comment there, or of course there is the onesandzeros.contact@gmail address that you can email us on, which is currently down there on the screen somewhere. Yep, down there. Love all of the feedback that I've been getting so far, so it's really good to see. So let's just make sure that the stream's actually behaving itself. Looks like it may be, which is always a good thing. Excellent. All right, so first things first, we're going to have a bit of a look at the particular tool that I use to do the font conversion into something that we can actually use for the STM32 microcontrollers. So let's jump over to this particular screen and let's have a look here. So the particular tool that I like using for this stuff is called the Dot Factory. And if you do a bit of a Google search, you will be able to find the particular download for this one. It is still available. It's one that I have been using for quite a while. So just bear with me a moment, just having a slight technical difficulty. Just give me 1 second. All right, that's better. Always better when the technology behaves itself properly. All right, so back to what I was saying. So this particular tool is called the Dot Factory, and it's really quite a useful tool. So what we're going to do first up is we're going to create a bit of a font that we're going to use to be able to do the testing of the font system today, and sort of show you a bit of a way where you can actually have multiple different fonts all set up so that you can switch between them as needed, different font sizes and all that sort of stuff. So as far as this particular tool, the way we go about it is first up, we want to select the font that we want to use. One of the ones that I am quite partial to is the Seago UI. I find it actually tends to look quite good on these particular screens. And we might go for a semi-bold one, and let's go for size 20 for the font. Now, as far as all of the text that we want to have here, let me see if I can find the particular, that's what we want. All right, so we'll just delete that. So we select all for the text, which then basically gives us everything from ASCII character 33 all the way to 127. It does also include the space there as well, which we can see, which is actually ASCII character 32. But we'll leave that one in there for the moment, and we'll click generate on that one. And we'll see that it does actually give us a bunch of data there that's already in C format that we can actually use. So we will change this stuff around a little bit, but basically the way this works is it basically sets the font up so that each pixel of each character takes up 1 bit of space. So you fit 8 pixels into a byte. So it's actually really quite space efficient. And you can find, especially if you're using something like the F769 Discovery board that we're using here, that you can fit quite a few fonts on it and still have a bunch of space left over in flash memory for code and other bits and pieces as well. So that's how we go about generating that. So we'll pop that over onto my other screen for the moment, and let's pull up the code that we want. So this is the code as it was after the last episode where we did part 3 of the LCD stuff. There has been some minor changes which have been happening to the code base, both for the F411 Nucleo as well as for this code for the F769 Discovery. So you'll notice there is, if we switch over to one of these files, I have gone through and started putting some fairly extensive comments through the code, and that's going to continue. So all of the code moving forward is going to be fairly well documented to make it a lot easier for people that are sort of new to it and getting into it and that sort of stuff as well. If you're interested in keeping up on sort of what those changes are and the things that are happening behind the scenes and what we've got planned for the videos moving forward, keep an eye out for the devlogs that I've started doing. So there was one that I did a couple of days ago, which sort of gave a really good introduction to what we're looking at moving forward, some of the devices we're going to be using and things like that. And if you've got any questions or anything like that that you'd like answered during the devlogs, definitely feel free to send those my way as well, and I'll look at getting those answered. So we've got our LCD class that we created that makes use of the LTDC driver that we wrote in part 1 of the LCD display code. Not enough coffee this evening. So basically, the way we're going to approach doing the font stuff is we'll be developing a couple of different classes. So one of them will be a font manager, which will integrate into the LCD class. The other one will be an actual font class. So there'll be one of those used for each of the fonts in order to sort of make things a little bit more efficient when we're switching between fonts and stuff like that. It tends to be an approach that I've come across that I quite like. So first things first, we're going to create a couple of files in our QAS_LCD folder. And we'll want a header file for that. So we're just going to call this QAS_fonts.hpp. And we'll create a source file for that as well. And we're also going to create a folder in here where we're actually going to be storing the header files that contain the font data as well, just to kind of keep those separate a little bit and keep things a little bit neater. So we'll create a folder for that one, which we'll just call QAS LCD fonts. And of course, we're going to need to add that to our include paths as well. So jump in there, that'll be for C++. And that will be QA_systems, QAS LCD, QAS LCD fonts. And make sure everything is spelled correctly. Now I'll do the same thing for the release configuration as well. So QA systems, QAS LCD, QAS LCD fonts, like so. Apply that, and that is that ready to go. Now we'll also create another file in this folder, which is going to contain our font data for the Sego UI font that we have generated. So we'll call that QAS LCD fonts. Make sure I spell that correctly. SEG OEUI and 20 point semi-bold .hpp. Alright, now we'll get some headers copied across. So grab that one, pop that in there, get rid of the bits that we don't need from here. Fingers don't want to type tonight. HPP, fix these guys up. And we are, what's the 5th of November today? Okay. Be happy with that stuff. Change that one to CPP. We'll be wanting to include our QAS LCD fonts. Get rid of this guy. And also copy this over to this particular file. This will be font data. And Seago UI 20 point semi-bold. Copy and paste that one so I don't have to retype it again. Alright. Now we're going to copy this font data across, so just copying and paste the stuff that is listed in source file. We're not going to worry about the stuff that is listed in the header file because all of this we're going to be leaving in the header anyway. And let's get a bit of this stuff renamed. So we're going to come back to that one in a moment. We'll start getting some of the stuff set up for our actual font system itself. We will also be including our LTDC driver in here as well. Also want to include string.h and I'm going to include vector. So we're going to be using a C++ vector to store the list of fonts that are currently in the system that we're going to have access to as well. So even though it's just going to be the one for the moment. So going to want to be able to store the name of the font. So just going to set up a define for that one for the moment. And we're going to set up a font description structure, which we will be using to help as far as the particular data for the font that we've imported in from .factory. And that will contain two uint16t values. One will be width, and the other one will be the offset. Now that one is actually going to get used, so you'll notice that there's kind of a couple of sections to the data. So we've got our first constant section, which is actually the bitmap data for all of the individual characters. So if we scroll down through that, we'll then see the second section, which is actually the descriptors, so determines how wide each character is in bits, as well as what the offset is in bytes. So that'll make a little bit more sense once we get into some of the other stuff as well. So I'm going to rename this guy to QAS LCD fonts Seago UI 20 point semi-bold description. And for this one, also need to be including in here our QAS LCD fonts.hpp file so that we can actually access that particular description. And let's just pop that over there so that we can see both of these guys side by side. So this will be, should actually be QAS because we're dealing with a system, not a driver. So that'd be QAS LCD font desk. And grab all of this particular stuff and move it up above the bitmap data, just because I prefer to sort of lay it out that way. This should be uint8t. And we're going to grab that name from there, pop that in here, and then rather than description, we're going to call that data. Grab this bit of info here. And we're going to pop that up there like so. And I tend to prefer using one header file for each specific font, just because the particular fonts do take up a decent bit of space as far as line numbers. So that way I find don't have to end up scrolling endlessly through particular files to be able to find what I'm looking for. So as we can see, we've moved our description data up above our bitmap data. And I'm not going to be able to help myself, but make sure that all of these are lined up correctly as well, because that's the sort of thing that will just drive me nuts if I don't. Now there will be a couple of other bits that we're going to need to fix up in here as well, just to keep the compiler happy. So if we scroll down a bit, we will notice like here where the slash is, the backslash, it doesn't like having that there, so I'm just going to rename that one. I think that's the only one that typically will give us grief. However, we will find out once we go to compile everything anyway. So as far as the font info here, we're going to basically rewrite that stuff. So go with constant uint8t, again sticking with the same naming convention for this particular font. So we're going to have our character height, which is 4, as we can see up here. And then we can see some of the other bits and pieces that we're going to need here as well. So this is the one where it talks about the width in pixels of the space character. So I'm going to go with 2. All this stuff can be fine-tuned as well at a later date if you're not happy with sort of how it's actually displaying. I'll try and get all this stuff out of the way first because it tends to be the sort of more boring stuff, I guess. The char gap is basically, we're defining that because that will be the gap in pixels in between each character. So we might set that to 2. We might actually set our space width to 3 for the moment, and we'll see how that goes. Just call that font data for the moment. And that's about all that we're going to need there. We don't need to worry about the start or end character or anything like that. And all of that looks pretty good for the moment. So that's basically the font data sorted out. Let's get some classes written. So the first one we're going to do is actually the font itself. So the particular class that's going to hold data for a specific font. And this will be one where, say if we had 4 fonts in the system, you'd have 4 of those classes, each linking to the particular data for that specific font. And again, it makes things a little bit more efficient when it comes to switching between fonts and things like that, which is why I choose to do it this way. So let's pop in. Now there will be more commenting and stuff coming in this code in future, but to save the sort of length of the video, that's stuff that I will be doing offline. So, and again, that's sort of stuff that I'll be sort of going into a little bit more detail in the devlogs as well. So this one we are going to call QAS LCD font. So we're going to have a couple of public sections. We could just have one public section, but I'm going to pop 2 in there just because it's going to help break up sort of some of the data that we're actually going to be storing for the font from some of the methods and functions specific to the class. So it sort of gives us two sections, and visually I find it makes it a little bit easier to identify what we're actually looking at. So this one will be the actual name of the font, which will basically be an array of characters that is the length of our definition here for the name of the font. That can be changed to suit depending on what you actually want to do with it. If you want longer or shorter font names, you can certainly do that. And then we will be having to store the actual data for the font itself. So we're going to have our font description, so there'll be a pointer to that. Going to have a pointer to the uint8, which is our actual bitmap data for our fonts. And then make those uint8s, let's make those 16s instead. Just that way it matches what we're going to be doing here in the actual class itself. So we need to know what the height of the characters will be, what our space width will be in pixels, as well as what our char gap will be, so the gap in between each character. So that's basically all of the data that we're going to need to be storing for each particular font. Get some constructors created in here. Now we're going to, as we've done a bunch of times before, delete our default constructor. And then we're going to create a constructor that allows us to basically fill out the particular data for the font. So provide it with the name of the font, a pointer to the description, a pointer to the font data, we'll pass it a reference to the character height, pass it a reference to the width of the space character, and also for the character gap. And then we'll do our member initializer list. So I haven't spelled that correct, so just fix that up. Okay, so in our member initializer list, we're just going to do our height, our space width, and our character gap. And then within the body of the constructor, we will then go through and fill out our description. Now, might actually, so there shouldn't be any reason why we can't just pop these guys in here as well. Some reason in some of my previous code I've done it a slightly different way, which I know why. I think I ran into a particular error as far as the pointers being passed as constants. So let's just do it this way, because we know this way works, because it's the way I've done it a few times before. And we can come back and modify it if needed at some point anyway. Now we also want to copy the name of the font as well. Curious as to what it's actually being unhappy about there. Ah, okay, these should be QAS. Now we're also going to create a couple of equality operators as well as an assignment operator in here as well, which will come in handy when we actually go to start using the fonts. So we're just going to code these up in the header file. So first up, we want one to be able to check if two particular fonts are the same. So this one will actually be checking based on the name of the font. So it's just going to iterate through the font name. And if any of the characters are not equal, then it will change our result variable to false. And then it'll return that. So assuming that all the characters are identical, we will actually get the same result. The other thing that we might do is, prior to copying over the actual name that we're passing into this constructor, we might actually fill the name with zeros, so that if there's any sort of spurious data left over in memory, it's not going to prevent this equality operator from working correctly. And then we're also going to do another equality operator, but this time, rather than passing it a font class, we're going to pass it an actual string, so that we can actually see if the string matches the name of the font that's stored in the class. So similar sort of approach. In fact, we might just copy and paste that code there. And the only difference we've really got to put in here is that one there. Now, that does mean that we could potentially end up with a buffer overflow. So what we might do there is we'll use string length to get the length of the name that's being passed into the operator. And then if that is less than our font name length, then we'll go with the let's do this a little bit more efficiently so that we're not actually having to call string length twice. And we'll call this one index length. So if uLength is less than that one, then we'll go with uLength. That should be a question mark. Otherwise, we're going to go with QAD LCD font name length. Like so. That way we're not going to get a buffer overflow for string name, which wouldn't necessarily be an issue because of the fact that we're not actually modifying string name, but it's still sort of better practice to make sure that we're doing it that way rather than actually allowing a buffer overflow to happen, even if we're only reading data from outside the potential buffer length. It's just kind of a best practice thing. And then we also want an assignment operator as well. So this one will be operator equals QAS LCD font. That'll be a reference to that one. Other. And then make sure that we copy across the required data. So we'll copy across the font name. Now we could just use string copy for this, but because string copy is working with null terminated strings, it's not going to copy across the entire, in this case, 32 bytes necessarily. So if one of the font names is only 5 characters and then the null termination character, so 6 bytes in total, then it's not going to copy across the rest. Whereas we want to copy across the entire 32 bytes of that name in order to make sure that everything is copied across the way that it should be. So that's why we'll do it this way. So MC name I equals other dot MC name I, and then we'll also copy across our description. Space width and our char gap. Alright, and that's basically that class done, except we also need to return a reference to the current class with that one. So that's our actual font class that stores our font data. And then that's kind of a bit of the boring stuff out of the road, which means that we can actually get onto some of the fun stuff where we can actually start to do things like setting fonts and getting them rendered and things like that as well. So I am just going to take a quick bio break before we get onto that one. So I shall be back in a few minutes and then we'll get stuck into that one. So And we are back. Alright, so for this particular class, we are going to be calling it QAS LCD Font Manager. Pop a few spaces down there so that we can scroll a little bit easier. Now, first things first is we are going to want to use a C++ vector to store our fonts. We'll be storing pointers to those guys, so let's call him MV fonts. We want some data to hold what our current font index is, and we might go with a signed integer for that one. We want to store a pointer to the current font that we're using. I'll just call that current. And let's get some of the methods popped in first up. So let's get a constructor sorted out for this one. So current index will be -1 because at initialization we won't have any font selected. And same for our current font, we'll set that to null. And that's about all we're going to do for that constructor for the moment. We are going to set up a destructor. Which will go through and basically clear out any fonts that are currently sitting in our vector. So essentially, if there is any fonts currently being stored, then we want to go through and iterate through those and delete each of them, due to the fact that we will be dynamically allocating them. In fact, we don't even need to do that, because if there's 0 of them, then our for loop's not actually going to iterate at all anyway. So let's just do it that way. And then we can go through and delete each of the fonts in turn, just to make sure that we tidy up at the end of it, so that we don't end up with any sort of memory leaks or anything like that. Now, as I mentioned earlier, there will be more comments being added to this code in future, but that's stuff that I'll be doing offline because I don't want to bore you with too much of that, but that will be coming in the following days. I am also in the process of getting some of the other drivers from the STM32 Basics series moved across as well, so I have already brought across the external interrupt drivers. Hopefully in the next day or two I'll have all of the timer drivers brought across as well, so the timer manager. There's also a UART manager which I have recently set up for that code, which will come across to this one, as well as the timer interrupts, encoders, and PWM drivers. So as far as our management methods here, we want to be able to do things like adding fonts, removing fonts, clearing the entire list of fonts, being able to find a font based on a particular name so that we can give a name to a font, give it a name, and it will actually find the particular font for us, as well as being able to do things like set the current font that we want to be using. So that's what these methods are going to be being used for. So you'll notice a lot of this stuff here is similar to what we did for the constructor for the actual font class, which there is a good reason for, because the font manager will actually be the one responsible for creating the particular font classes. So when we go to add a font, it will actually create the class for that, fill out the correct details for it, and add it to the vector so that it's part of the currently available font list. So we'll also have a method to be able to remove a font, and we'll just do that based on the particular name of the font, so that we can tell it which one we want to remove. Have a method to be able to clear all of the fonts. Have a method to be able to find a particular font based on its name. And then we're going to have a couple of different set font methods. So one that allows us to set a font based on its particular name, as well as one to be able to set a font based on its particular index in the list as well. So that will be a uint8t, and we'll just call that index. So we'll get these guys coded up first before we finish off the other ones. So QAD LCD font manager, management methods. one too many of those guys in there. Curious as to why that's decided that that's not a comment, but I guess we will find out shortly. Got to be something there that we've missed. That's better. All right. So for these particular methods, as far as adding a font, so basically allocate a new font, passing it the particular details. And then once we've created that one, we can then add that to our vector. Like so. Now, for this one, it is actually going to use the find method, which we haven't coded yet, but that's okay because we're going to get to that one in a moment. And then if index is greater than or equal to 0, it means that it's found a matching one. So the find method will return -1 if it hasn't found a matching font, or it'll return 0 or above, or the actual index of the font inside the vector if it has found it. So in this case, if it has found it, then we want it to erase that one. Like so. And I've made that same mistake again of using QAD instead of QAS. Good old find and replace will fix that up for us. That's a bit better. Clearing them will be pretty easy. So we can just use the clear method for the vector. Like so. As far as our find method, start with an index which will put -1 in, which will be the result if we don't manage to find a matching font. And then we will iterate through the fonts that are in the vector. And then this is where we can actually make use of our equality operator. So it allows us to just go if mv fonts I equals string name, then we'll set I index to the index of the font that is found, and then it can just return that as the result. As far as setting the fonts, use that same find method to find if there's a font with a matching name. If it hasn't found one, so if I index is less than 0, then we'll set our current font index to -1 and set our current font pointer to null. Otherwise, we'll set our index to the index that we've found, and we'll set our current font to the particular one that is in the vector, like so. Now, as far as setting a font based on the index, it's going to be a little bit similar. It's first going to check to see if the index is within the amount of values of what we've got in the vector. So say if we had 2 fonts in the vector and we pass this function an index of 4, we don't want it to try and set a font based on that because it doesn't exist in the vector at that point. So again, we'll set our current index to -1 and set our current font pointer to null. Otherwise, we will set our current index to the one that's been supplied to the function and set our current font pointer to the item that's at that index in our vector. So that's those methods. Now, trying to figure out whether I'm going to modify it based on the way I've done it previously, or if we're going to stick with that particular approach. Always like to try and improve things along the way with each sort of iteration of my code if I can. We might stick with that for the moment, and then we can optimize it later on if we choose to. So I'm going to pop in a private section. And allow us to retrieve a copy of the font description. Have to declare that one as constant. And get data. That one will also be declared as constant. And label some of this stuff up a little bit so it makes it easier when I come back to get all of the commenting done. So as far as these methods, these will just be used to return the height, space width and char gap of the currently selected font. This guy will return the width of a specific character. So say if we want to know how wide the capital letter A is, then we can pass it to that and it will actually tell us how many pixels wide that is. Much like what we're doing with get string width, so that we can actually pass it a string and it's going to tell us what the width in pixels is of that particular string. The benefit of that being that when we go to do things like right aligning or centering text on the screen, we kind of need to know what the width of the string is going to be in order to be able to do that accurately. And then we're also going to have some rendering methods, which are the most important ones. Now, if we jump into here, we've got our set draw buffer and set draw color methods there, which I also want to be setting the draw buffer and draw color for the font manager as well, so that when we go to draw text, that stuff's already set just as it is if we were going to draw any of our other sort of primitive shapes as well. So let's jump back to this one. So keep the naming convention fairly similar. So that needs to be appointed to a QAD LTDC buffer. And that one will be just a uint16t for the color, given that we're doing 16 bits per pixel for the way we've got things set up at the moment. And then we need some methods to be able to draw individual characters. And for this, we're going to be using our vector2 class that we've created for that one. And provide it with a reference to the character. So that one will draw a left aligned string, and have one to draw a centered string. That should be a pointer rather than a reference. And we want one to be able to do a right aligned string as well. And then we're also going to have a private methods which is going to be used by our other draw methods. And as we go, I'll kind of explain why we're taking that sort of approach with that. So let's grab all of these guys, pop them in here, and we'll get these fleshed out and chuck some code into them. Might be helpful if YouTube was actually playing some half-decent music. Let's just get that fixed up. Can't write good code without decent music. It just doesn't work. Let's go with that one. That's better. All right. Now, as pointed out by some people previously, I could just go through and use touch GFX to do all of this stuff, but given that a lot of my earlier programming days was messing with game engines, I actually really enjoy doing rendering code and trying to make it efficient and messing around with it and things like that, which is why I do it this way. I also think it's a really good way of getting a much better idea of how sort of the graphics subsystems work and different ways that you can leverage them that you may not be able to necessarily by using third-party libraries. Not that I have anything against third-party libraries. They can certainly make things a lot quicker as far as getting projects up and running, but I don't know, just kind of love doing this sort of stuff myself. Get that extra bit of sense of satisfaction. So I've got all of those prepared. All right, now on to the fun stuff. So not too far off having all of this done, which is pretty cool. That should be returning a 0, same as that one. And those guys are correct. Make sure I get these guys correct. Should be space width. Based on the lack of coloring in the code, I'm guessing we have bug somewhere or another. Let's just try building that and see if we can't track down where that is right now. Okay, just a few errors. That's that one. Well, that sorted most of those ones out pretty quickly. Where's that last one hiding? Uh-huh. Ah, okay, that should be a U. Vector is declared in the tools, which means we need to be including that as well. Okay, that should be I index. Aha. Alright. Might help if we let the compiler know what these methods actually belong to. That's probably a really good start. Let's see if that gets rid of most of them for us. Back down to 4 errors. Two warnings because we're not providing return values, and this should be QAD because that's part of the LTDC driver. Alright, back down to 0 errors. Now we're getting somewhere. Alright, so get char width. Let's do a bit of here's one I prepared earlier. Same for this one. So basically, as far as get char width, it's basically just indexing into the particular character that it's looking for. And again, our font data contains ASCII characters 33 through to should be 127. Not sure why that code has 126. Let's change that. And there as well. And basically, as far as get string width, it's going to go through and do something similar. So it's going to get the char width. However, it's going to also add the character gap, so the gap in between each character for all of them, and then it's going to subtract one character gap because you want one less character gap than you've got the number of characters, because you don't want a character gap on the end because it's unnecessary. So you just want one in between each of the characters. So say if you have 4 characters, then there's going to be 3 gaps in between those 4 characters. So it's kind of the way that we're doing that. Now we also want to be able to store our current rendering buffer in here, which will be a QAD LTDC buffer pointer. And we also want to store what the current color is that we're drawing as well. So we'll pop those guys into the correct class, would help. That should be in the manager class where we want those. Line all of those up properly so that they look nice and neat. So in this case, did call it draw. Should I know? We'll just go with buffer rather than draw buffer. Alright, now to skip these four for the moment because it's going to be the draw P method that's actually going to be responsible for drawing individual characters. And again, we're just going to copy and paste this fella here. So basically it's going to figure out which character. It's going to grab the width of that character as well as the offset to get to that character within the actual data, and then it's going to iterate through that data. Again, because there's 1 bit per pixel, for each byte it's got to go through and draw 8 pixels for that particular byte. So I'm not going to go too much into this particular algorithm at the moment. However, this one will be going up on GitHub anyway, so if you are curious and you want to sort of get into having a look at how that actually works, then feel free to mess with it a bit. It's one I came up with quite a while ago when I discovered the dot factory software, which is something I've been using for at least a few years now, I think. Simply because I love the fact that I can take just about any Windows font and convert it into something that's basically usable for working with the LCD screen. It doesn't allow for anti-aliased fonts, but given the performance benefit and the fact that on this sort of screen, on this Discovery board that's 800 by 480 pixels, it's not really too much of an issue. So as far as our method to draw an individual character, it's basically just going to check to see that there is actually a buffer assigned for it to draw to, and that the font index, so that there is actually a font selected, and then it's going to call drawchar P to actually draw that one at the specific position. And similar sort of thing for drawString left. So same thing, it's going to perform those same checks. It's going to figure out how many characters it's got to draw, and then it's going to iterate through those and draw those, adding on the string width and the character gap for each one so that they're spaced out correctly. Drawstring C to draw centered text is fairly similar again, with the main difference being that it will actually figure out what the length of the string is, so where it gets the string width, shifts it right 1 in order to divide it by 2 so that it can then work out what the offset is in order for the text to be in the middle. And drawString right again is fairly similar because it's just calculating the width of the string that it's got to draw and then using that as the offset in order to make sure that the string is right aligned. So there's a few things that will need to be changed here based on the differences between the code base I've just copied this stuff from. Seven errors. What do we got? Okay, so that should be U width. Same thing there. And then down here we're going to have same thing, that'll be U width and U offset, and this will be MU color, so that everything matches the current bit of code that we've popped in there. Still 2 errors. Excellent. Alright, so that's basically those driver classes done. And now there's just a few bits and pieces we've got to do in order to get access to those particular methods so that we can then go through and actually get stuff being rendered. Which includes adding our fonts to the font manager, as well as making sure that the buffer and color set methods in our LCD class are also setting those same details for the font manager, and then also adding the some of the draw methods from the font manager so that they're then accessible from within the LCD class as well. And once that stuff is done, we can actually go through and try it out and see if we can get some text being rendered. So we're going to jump to our initialization here for our font manager. So we're going to jump into our LCD class. We'll pop a font manager in here. We'll need to make sure we include our fonts.hpp, and so that we can actually add our font, we want our QAS LCD fonts Seago UI 20 point semibold.hpp. Missing an E from that one. There we go. Gonna want a QAS LCD font manager for that one. And in our constructor for this one, might even while we're here, set our draw buffer to null and our draw color to 0. might even pop some of this stuff in the initialization method as well. So MC font manager, add just give that to it as the name. Description for that one will be QAS LCD fonts, SIGO UI 20 point semi-bold. Description, QAS LCD fonts, SIGO UI 20 point semi-bold data. QAS LCD fonts, SIGO UI 20 point semi-bold height. QAS LCD fonts, SIGO UI 20 point semi-bold space width. It's a bit of a mouthful. 20 point semi-bold char gap. Which will add the fonts there. Now we might even get the font manager to clear out its font list when this is deinitialized. Okay. Now we need to do set draw buffer to MP draw buffer and MC font manager set draw color to MU draw color, like so. Right. Now, nearly done. We need to go through and pop some font rendering methods into our LCD class. So we're going to need to be able to set the fonts, and much like we did for the font manager class, we want to be able to do it so that we can set it based on either the font name or on the index into the font in the vector that is holding the font list. So that will be set fonts, string name. We'll get these implementation methods popped in a moment. uint8t, uindex, and doing it this way with static methods and then the implementation methods due to the fact that we're using a singleton class as well, which if you've seen some of our previous videos, you'll have a bit of an idea about what we mean by that. Draw a string left, vector 2, C pos, and that'll be a constant char string. And one to draw a string that is right aligned. And the cool part is even though we only have some fairly simple methods for being able to draw stuff like simple lines and rectangles and stuff like that, and we are going to add some stuff using the DMA2D and things like that, but it's amazing how much of a really usable and quite decent looking user interface you can actually develop just using really simple and quite efficient rendering methods. Let's make this a bit easier and split that one there so that we can see which ones we need to pop in here. So we've got imp set font, const char string name, void imp set font, uint8t uindex, void imp draw char, vector 2 C pos char ch, void imp and draw string left, vector 2 C pos const char string, and center and right. Chuck these guys down here. So QAS LCD font rendering methods. Made that same mistake again. There we go. I'll fix that bit up. Alright, so these ones are all going to be nice and simple because we're basically just going to be directly calling the methods from the font manager. In fact, there may even be an easier way to do it. Let's do it that way. Let's get rid of those. Get rid of those. And let's call these all directly in here. Yep, that's going to work like a charm. Much simpler approach. I like that. Alright, but does it build? The way's the fun part. How about that? 0 error, 0 warnings. Alright, so let us see if we can render some text. So we might pop this on layer 1. Let's go with some black text. Now we've only got one font in the system, which will be at index 0, so rather than setting it by its name, we'll just do it that way. Now, let's just draw it in the middle of the screen, somewhere near the top. And why not just go for the good old hello world? is ambiguous, right? Okay. Makes for an interesting error. Alright, let's just, for testing, get rid of that one, which should get rid of that particular error. And let's see if that runs. We can come back and fix up that other error at a later date, considering that we are now over 2 hours into the stream. Of course you want to file to start the GDB server. Which bit of software is it that's deciding it wants to mess with it this time? It's probably one of those two, because that's typically what the deal is. Yep, definitely was one of those. Well, we have something, but it's not quite what we want. It's attempting to render something, which we can see some stuff showing up here, which means we're close, but not quite there yet. So let's figure out why it is that that's the case. Okay, where are we setting up the actual font manager stuff here? Have we done that bit correctly? So description, data, height, space width, char gap, that's all correct. Height doesn't seem quite right. Guessing that's potentially where the issue is. So if we have a look at, we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 25, 26, 27. Which is what I think it should be. I think the font converter was lying to us when it gave us the numbers. So let's try that, because that seems like it could be a thing. definitely closer than we were. So that was definitely part of the problem. See if we can get a bit better view on that. I don't know if it's going to focus. It's definitely trying to do what we want, but just not quite. The widths look good. The offsets look good. Don't think we're overflowing on that at all. They're being stored as UN16Ts. They're being passed through as UN16Ts, so that's fine. So let's change what we're actually drawing to it for the moment. Let's just go with 4 of them. See if we can spot the pattern that is occurring. Curious parts that also drawing it in an incorrect position. Let's tell it to draw it left aligned. Is it going to build, or is there an error there? No error. Alright, let's see what we get. It's a rather interesting pattern. Alright. And just to chase that pattern a little bit further, it seems to be drawing letters inside out, which is kind of interesting. So there's some sort of weird offset thing going on here. Okay, which means that the issue is most likely in this particular rendering method. Which is rather random because this is code that I've used previously that has actually worked. So let's start by ruling some stuff out. This is a font that I know has worked previously. So that we can figure out if it's actually the rendering method or the font data that's being a little bit strange. So we're going to go into here. Include this file. So that's 12 points. Alright. Now that should add that to font index number 1. See if that will build for us. 6 arrows, where's arrows? Oh, we're going to have one there, no doubt. So it should be QAS LCD font desk. Let's see how that goes. How about that? So it was corrupted font data. The code was fine. The data was being a bit of a dick. So if we pop that back there, and let's get rid of that. Let's go with that. And let's try that out. And we have hello world. See if it will focus on that. Alright, so at some stage, not during this stream, but at some stage, I will figure out what the particular issue was with that data being corrupted. I'm guessing it's going to be a rather tiny step, but at least we know the font rendering all works now. Even if we are only getting tiny 12-point font, but thankfully, and due to the awesome new camera that my good friend has supplied for the streams, we can actually see that quite well on the stream. So I'm going to call that a success for the night, especially after nearly 2.5 hours worth of stream, and the second stream for the evening. So hopefully anyone that did make it this far has maybe learned something and enjoyed watching a little bit. If you did, I would love a follow on Twitch or a like and subscribe on YouTube. Definitely going to have some more slightly shorter videos coming soon, and that's basically all 4 parts of the LCD stuff done for the Discovering STM32 series. So get on to doing fun stuff like the touchscreen and things like that next, which is going to be a bit more fun. And also got some FPGA videos and stuff coming up as well. If anyone's interested in sort of what's coming up on the channel soon, then check out the dev blog that I put out the other day, because there's a lot of really cool info there. If you've got any questions or anything like that, feel free to leave those, and I'm more than happy to follow up on those. So we've got I either leave them on Twitch or YouTube, or there of course is the r/ones and zeros subreddit, and the onesandzeros.contact@gmail.com as well, that you can get in touch by. And also, as I've mentioned in a couple of the videos now, there will be some development boards getting given away once we reach 100 subs on YouTube, as well as stuff getting given away when we reach most of our milestones. So keep an eye out for that. And if you want to score some free microcontrollers, definitely help get some more people subscribed. So hope you're having a great day or night or evening, whatever it is, wherever you are in the world, and thanks for watching.